Solve the following differential equation by using integrating factors. Use C as the constant. So there's our differential equation. How do we do it? Well, here's the steps from the class notes. First step, put the equation in the form dy dx or y prime, same thing, plus something times y, and then the other stuff on the other side. So I gotta get the dy dx and the y on the same side. So let's do that first off. So that means I'm going to grab this term and bounce it over to the other side. So I've got y prime minus 4y equals x. Okay, so there's step one. Step one. Step two, find the integrating factor, which is e to the integral p of x dx. The p of x is whatever's next to y. Okay, so let's see here. It's what they're calling p of x, and the integrating factor mu is e to the integral p of x dx. So that's e to the integral. In this case, that's minus 4 dx, because that is the integrating factor. I'm sorry, that is the p of x. And so what does that equal then? E to the minus 4x, right? That's the integral, because the derivative of minus 4x would go right back to minus 4, wouldn't it? So that's what we call the integrating factor. Now, step three, multiply the differential equation by that integrating factor. Boom, boom, boom. Oh, so I'm going to use this now, and I'm going to multiply this there, there, and there. So I'll get y prime e to the, this is step three now, e to the minus 4x minus 4y e to the minus 4x equals x e to the minus 4x. Okay, step three. Now, step four. The left side is the derivative of the product of mu of x and y. Oh, it is. So the left side will be guaranteed, oops, to be that product. Let's see it. So the left side is d dx of, what they say, y, and this thing that the integrating factor from step two. They're saying that in the right side, nothing's happened. Is that true? Well, if we took the derivative, two things multiplied, how would you take the derivative? You do the product rule, right? You take the derivative of the first guy, that'd be y prime times the second guy unchanged. Oh yeah, that does look good. Plus, now it's supposed to be plus, and then you take the first guy unchanged times the root of the second guy. What's the root of the second guy? E to the minus 4x is himself, but times negative 4. Oh, that's where the negative 4 comes from. Yeah, it's true. See how that always works? The derivative by the product rule. So this is the derivative of that. Now, why is that so great? Now, um, step five, integrate both sides of the differential equation. Oh, so on step number five now, we're going to go up and we're going to go integral. Well, here, I'll do it on a new step. Integral, integral of what? Of d dx y e to the minus 4x equals integral of x e to the minus 4x. And whenever you integrate both sides, you're going to have a constant. So I'll put in the c there. They told me to use c as my constant, right? Whenever you integrate both sides. Okay, what's going to happen? Well, an integral and a derivative are going to cancel each other out. They're opposites, remember? So this is just y e to the minus 4x equals. Now, what's the integral on this side? You can put a dx if it bugs you. What's the integral there? How do we do that integral? Well, we're going to have to do by parts. Going to have to do by parts. Now, let me give you a trick for doing by parts more quickly. Let me show you. Here it is up here. It's in the notes. I put it in the notes for you. It's called, here's the normal way we did by parts, and that's great and everything. But here's a shortcut. This is a shortcut method for integration by parts called the tabular integration. So what do? You put your first function on the left and your other stuff on the right. And on the left side, you go derivative, derivative, derivative till you get down to zero. And this side, you go integral, 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 and then you put these diagonal lines, you go plus, minus, and that's your answer. It says it all right here. Derivative on the left side, integrals on the right side, and draw diagonal lines. First is plus, second is negative, etc., etc. Let's do it. Let me show you. So we're going to say, oh, okay. So I'm going to go tabular, tabular, biparts. Just a shortcut for biparts. So what do I mean? Well, I mean I'm going to literally go take that x here, and I'm going to go e to the minus 4x there. And I'm going to go derivative. What's that? 1, right? Derivative, 0. Keep going till you get down to 0. This side, you're going to go integral. I'm going to integrate. How do you integrate that? Well, it's going to be minus 1/4 e to the minus 4x. How do you know? Because if you took the derivative, go back. If you took the derivative of this, remember, e to the whatever does nothing. But then inside whatever's plugged into it is not a simple x. So chain rule go times -4. That would cancel this out. It would go back, wouldn't it? And let's do it one more time. And then integrate again. And what do you get? Well, this time it's going to be minus 1/16 e to the minus 4. See how that's right? Because if I take the derivative, it would go back, right? Because that e to the minus 4x, that minus 4 would pop out. Two minuses. Oh, wait. Oh, no, that's supposed to be. Yeah, is that supposed to be plus? I think I'm checking it. Yeah, that's supposed to be plus, isn't it? Okay, there we go. See how I always check it to make sure it'll really go back with the derivative. Now it will, because that minus 4 will pop out, and minus 4 over 16 is minus 1/4. It'll go back. Oh. Okay, so there's that. Now, what do we do from here? Now we connect these like that. Diagonal lines going down. Diagonal lines going down. And this one you put a plus, and this one you put a minus. Like that. All right, did you see that in the notes? All right, this little tabular method right here. X, you just keep going down till you get 0. Other side, just do the integral. That was the easy one. And then you go diagonal line, diagonal line, diagonal line, plus, minus, etc. Okay, so what does all that mean? Oh, well, that means the right side has become, here we go, x times minus 1/4 e to the minus x. So that is minus 1/4 x e to the minus 4x, right? I just put all that with that, and there's a plus. So it's positive times negative, so it'd be negative. Next one, 1 times this, but there's a negative on it. So it's negative 1 times 1/16 e to the minus 4x, plus the constant still. On this other side, let's bring it down. Like that. Okay, we're almost there. We're now, what are we trying to do? We're trying to get y alone. Last step to get y alone. Somehow we have to get rid of this guy. How can we get rid of that guy? Well, here's what we're going to do. We're going to multiply by e to the plus 4x. Why? What will that do? Remember, the powers will add 4x minus 4x to be e to the 0 to be 1. Remember that rule? Like if you had x squared times x cubed, that'd be x to the 5th, the powers add. So if you have e to the 4x times e to the minus 4x, that's e to the what? 0. 4x minus 4x is 0, which is 1. So that'll effectively cancel it out. Whatever you do to one side, you got to do e to the 4x there, and you got to do e to the 4x there, and e to the 4x there. You got to multiply all the terms. Okay, so this and this will effectively cancel out. We'll get y alone. This side is going to, this and this will cancel each other out to be e to 0 or 1. So it'll be minus 1/4 x minus 1 times, and these will cancel out to be e to 0 or 1 times 1/16 plus c e to the 4x, right? C to the 4x right there. And you don't need that minus 1, huh? It's just minus 1/16. And so there we go. We got y alone. That is the solution. That's the function that will solve this differential equation. That's a function whose derivative is 4 times the function plus x. You could check it if you wanted to. You could plug it in and see if the derivative of this function is equal to 4 times the function plus x if you had time. Or you could just look right here in the answer key. Right? Did we get it right? Minus 1/4 x minus 1/16 minus 1/4 x minus 1/16 plus c e to the 4x plus c e to the 4x. There we go. So that's how we do that.